lesson. We are, once again, taking that trigonometry that we spent so much time on and applying it to real-world situations. Before we get into those actual real-world situations dealing with these vectors, we want to kind of establish that we get the vocabulary associated with vectors. So a couple of things about vectors. You'll see them labeled in your notes as they look like rays in a coordinate plane. Okay? And just like a ray, they have an initial point and they have a terminal point. When we're talking about vectors in this course, our initial point is almost always 0, 0. The only time the initial point is not 0, 0 is when I'm taking two vectors and adding them together. We'll get to that later. Okay. The terminal point is the point that we use to identify the coordinates of the vector. Okay, and we use the coordinates, that x comma y, in the exact same context as we've been dealing with x and y before. The only difference is instead of in parentheses, we see them in kind of arrowed brackets. Okay, but it's referring to the exact same point. The magnitude of a vector is basically the length of that vector. So what kind of values can I never ever have as the magnitude of my vector? If it's the length, I can't have any negative values. Okay? Also, a vector has direction, and we'll be talking about directions in terms of north, south, east, and west. All right, so let's begin. In problem 1, we are asked what is a vector AB as an ordered pair. What you need to realize is that we're trying to find the x and y coordinates of that terminal point B. And the way that we do that, using our trigonometry, is to realize we've got a right triangle here that we have the tools to solve for. If you haven't already pulled out your calculator, you're going to need it. So my horizontal segment of that triangle, that's going to be the x-coordinate. My vertical segment, of course, is going to be the y-coordinate of my vector. Tell me about the signs of my vector. Tell me about the signs of my vector. Will my x be positive or negative? Will my x be positive or negative? Will be positive. How about my y? Negative. Okay, so be mindful of the fact that the coordinates of a vector could have negative numbers in them, but the magnitude of a vector is always positive. All right, so any thoughts on how we're going to find x? Let's go alphabetically. How will I find x? Triangle. What is x to that 49-degree angle? Opposite, adjacent, hypotenuse? It's adjacent. How about the 15? It's the hypotenuse. So I hope that you realize you're using the cosine of the 49 in order to find the x-coordinate of your vector. So cosine of 49 equals x over 15. In your calculator, you're taking 15. Oh, that was not good. 15 times the cosine of 49. And it says round my coordinates to the nearest tenth. So my x-coordinate is 9.8. Now, of course, we can use trigonometry to find the y-coordinate of it. There is another way, however. What is the other way? Yes? You could use Pythagorean's theorem. Makes no difference to me how you solve for the second value. If you want to use the trigonometry because you know that's something you need more practice on, by all means do so. If you want to use the Pythagorean theorem because you think you need more practice on that, go for it, whatever works. Myself personally, I'm going to use the trigonometry. So, what trig ratio will I be using then? I'll be using the sine. And my y coordinate, the y that I got in my calculator is 11.3. Remember what you already told me about my y coordinate. What did you already tell me about my y coordinate? It's going to be negative. Good. Okay, so let's make sure that we express our answer in the format that it was asked of us. It was asked of us as an ordered pair, so we're expressing it as 9.8, comma, negative 11.3. And you'll notice in your notes that on the front it skips from problem 1 to problem 3, and then on the back there's problem 2. I did it that way so that I'd have enough space to do the work for problem 1 and do the work for problem 3. Problem 2 doesn't require a whole lot of work. So let's go ahead and go to problem 2 now. We have from this screen what we need. Still good. And by all means, some of you may be looking at problem 2 and thinking, you know this? Easy stuff. Wonderful. So in problem 2, it is asking us for the direction of each vector using compass directions. As I mentioned earlier, we're referring to these directions in terms of north, south, east, and west. Okay, so you'll hear phrases like north of west, or east of south, or south of west, things like that. So in that context, taking a look at part A of problem 2, does someone have an idea of how I would describe that angle, that direction? Yes. It is north of east. Fantastic. It is 31 degrees north of east. Part B. Someone else, please. Adrian.
Did you say it was east of
No. Good question. East of north would be fine if I was talking about the 59-degree angle that's up here. Okay. So I know there's always some confusion about what word comes first. Realize you're always going to have a vertical segment or a horizontal segment being one of the sides of your angle. Okay, so here my horizontal was east. There's my second direction. Okay, so the second direction is always either the vertical or the horizontal part of your angle. If that helps, run with it. You want me to write it down? What? All right, let me try that again. Hello. It's typing so slowly. Oh, good grief. The vertical or horizontal side of the angle is always the second direction. Okay, so looking at part B, there's a horizontal or a vertical line that is a side of that 36-degree angle. Oh, step by step. Is it horizontal or vertical? There's a horizontal or vertical side to that 36-degree angle. Is it horizontal or is it vertical? It's horizontal. Okay, narrowing it down. Is it west or east? West. West is going to be my second word in this direction. Okay, so it's going to be 36 degrees something of west, south of west. Abigail, you good? We have from the screen what we need? Okay. Getting through this quicker than I expected. Problem 3. I have a ship beginning a cruise and docking 120 miles east and 45 miles south of where it began. Look at how nice they are. They're even expressing it as an ordered pair. So they're asking us to the nearest tenth, what are the magnitude and direction of the trip vector? Realize, ladies and gentlemen, all they're asking us here is the exact opposite of what was asked of us in problem 1. Remember, in problem 1, they gave us the direction and they gave us the magnitude. They asked us for the coordinates. Here they're giving us the coordinates. They're asking us for the magnitude and the direction. You can do this. Okay? So what might be helpful for some of you is sketching the vector so that you're seeing where the sides are, where the angle is. Okay, so here's my coordinate plane, and my vector, here's 120, here's negative 45. My vector is there. Now I'm being asked for the magnitude and direction of the trip vector. A question that may be kind of sitting in some of your minds may be, okay, Mrs. Cox, I get how to come up with the magnitude, but what direction are they asking of me? Realize, let's deal with it in the order that they mentioned it. He's going 120 miles east and then 45 miles south of where it began. Let's find that angle. Okay, by all means, I don't think there would be anything wrong with finding the other angle. Just realize you'd be describing the angle a little bit differently. Instead of south of east, do you see if I found the other complement angle, I'd be looking at east of south, yes. The magnitude, not a stupid question, is the length of the vector. Okay, and when you draw this extra segment here, I would hope it becomes kind of clear to you how you're going to find that magnitude. Does someone see how we're going to find that magnitude? How are we going to find the magnitude? Let's realize what we know here. This 120, that's that. This 45 is there. Yes? Straight Pythagorean theorem. Like squared plus like squared equals hypotenuse squared. Let me confuse that very long. Okay, so 100. Oh, it really hates me. Okay, so 120. Definitely Friday. Okay. 120 squared plus 45 squared equals, let's use a variable that makes sense in the context of our problem, m squared, m for magnitude. And then in our calculator, we simplify and solve. Right? Realize what this 45 is. That's a vertical segment. That's the length of the vertical segment of the right triangle. So, this is 45 plus 14400. I have 128.2. Can someone verify that they did their calculations and you got the same thing? Okay. So we found magnitude. Last thing we need to find is the direction of the trip vector. Now, by all rights, you could use this 128.2 in the trigonometry that you're going to do in the next step of the problem to find the magnitude. However, can someone think of why I would advise you against it? Why would I advise you against using the 128.2, even though we've run the calculations, they've been confirmed by another party? Why would I advise you against that 128.2? What kind of decimal? Is it an exact decimal? No, it's an approximation. That's why I would advise you against it. Okay, use the values that are exact. You'll get closer to the right answer. Okay, so if only I'm using the 120 that's my horizontal and my 45 that's my vertical, what trig function am I using in order to find x? Since I'm not using the magnitude, which was the hypotenuse, right, I'm using the tangent. So tangent of x is 45 over 120. Remember, when you're finding the measure of an angle in your calculator, this is when you're using that inverse function. Okay, so what you're finding is the inverse tangent of this 45 divided by 120. Not bad. I have 20.6. Someone ran the numbers and got the same thing? Fantastic. Okay, so the direction is 28.6 degrees what? South. Thank you. Did I mention it was Friday? 20.6 degrees south of east. With that problem. Actually, you know what? We're getting through this with such ease. Just going to get through the whole thing. Okay? And then Monday will probably be a workbook day instead. Yes. Okay? That's what I have for my magnitude. 128. Okay, well, did we need this previous screen? We had it. We doing all right? We got it? All right. All right, in problem 4, they're asking for the resultant of two vectors. Don't panic. All you're doing is adding the vectors together. So look at what happens visually when we do this. I'm going to take vector A and plot it on my grid. So vector A is at 5, 2, 1, 2, 3, 4, 5, 2. There is vector A. And I'm going to take vector B and start it at the terminal point of A. In other words, I'm going to start B where I ended A. So from there, I'm going to go left 3 and then up 3. So left 3, 1, 2, 3, and then up 3, 1, 2, 3. There's my terminal point. This is B, which means that my resultant E is now this vector, whose coordinates are what, comma what? 2, 5. Bless you. And take a moment, look at the original vectors, and scoff at how easy this is and how you don't need a graph to do it. Are we scoffing yet? Scoffing, not coughing. But it's so easy. You see it? I'll just kind of, see it with the files, but you see it now? Just adding the vectors, literally. Just add the x coordinates, add the y coordinates, boom, done. Okay? Oh, look at that. We'll get through the whole thing yet. Yay. Of course, I'll be modifying the assignment, which does not necessarily mean just giving you more work, okay? All right, in problem 5, I have an airplane flying due east at a certain speed, and then there's a crosswind blowing the airplane south 15 miles per hour. I mentioned previously how these vectors come into play when you're dealing with physics later on in your science career. Some of you are like, no, I don't know physics. But, some of you eventually will, especially those of you engineering academy. So what is the plane's resultant speed and direction? Once again, might be helpful to consider it in a coordinate grid. Okay, so the airplane is flying due east at 275. So that's this is 275. And then there's a crosswind blowing due south at a speed of 15 miles per hour. So it's pushing him down at 15 miles per hour. My resultant vector is that green one that I've just drawn. So I'm finding its speed and direction. That's just magnitude and direction all over again. That's problem 3. Just phrased a different way. Okay? So tell me again how we found that magnitude back in problem 3. Pythagorean theorem. 15 squared plus 275 squared equals my magnitude squared. And I have 275.4. Can someone confirm that you did the calculations, you got the same thing I did? Yes, okay. So that is the plane's resultant speed. Now we need to find the plane's resultant direction. This time, since we're dealing with a real-world situation where this plane was intending to go east, but this crosswind is pushing them south, I don't want to think along the lines of, well, either one of these angles is okay. I want to think along the lines of, that's the angle that he ended up traveling. And once again, what trig ratio might I use here? The tangent. Of course, again, let me emphasize, because we now know the hypotenuse, you could, if you really, really wanted to, use sine or cosine. But again, I'd advise you against it. That 275.4 is an approximation, whereas the 275 and the 15 are exact. Okay, so tangent of x is 15 over 275. And I have 3.1 degrees. Can someone verify that they crunched the numbers and got the same thing? Okay? So 3.1 degrees, how? 3.1 degrees south of east. Okay, I'll be activating a daily quiz on Socrative. Before I do so, I have to end the first daily quiz. Did everyone take the first daily quiz that we started our class period with?